Everyone's here? Good. We're talking syscalls part 1. Okay, so we're just gonna go through a bunch of syscalls and they're all gonna be very useful. The first one is open. What do you think open does?
It opens a file.
It opens a file, and that's always a trick question on the exam. It also creates a file if the file didn't exist. So it opens an existing file or creates a file. Now, what do you have to give it? You have to give it a path name, which means like where you want it to open. Like /user/ Nahum / Unix files, those are bad names, / homework, and then the name of the file. The name of the file is also there. What if you don't write a path and you just write the name of the file? Just write like my file. It's wherever you're running the program. If the program is being run in your home directory, that'll be in your home directory. If the program is being run in root, then it'll be in root. So then we have these flags, which we'll explain in a minute. The flags are like, how do you want to open it? For example, read only. You could open a file for read only, which means that you can't write to it, but you can read to it. Or you could write only. You can only write to it. You have to decide how you're going to open it, or you could do both, read and write. Now these, if you notice, are all in all caps, because they're actually numbers. These are just defines. These are actually numbers. And since they're numbers, you can use the OR operator. Now the OR operator exists in C++ and in C and in all high-level languages. It's the OR operator. What it does is it's a bitwise OR. So like if this number, let's say, I don't know what these numbers really are, but let's say, here's an example. Open temp name, and then open, what is it, WR, that's write only. Or is that read? Read, right. Write, read, actually. Write, read. Right, read only. No, it's write only. Right, this is read only. This is write only, and
that's read and
read write is open, read, write. So
yeah.
WR is write only.
Yeah.
So I did like this. I did a weird thing. Let's say write only is the number 1. And let's say that open append, which means right at the end of the file, not at the beginning of the file. Let's say that's 2. And then create means that if the file doesn't exist, create it. So that would be, let's say, 4. So imagine that this is 1, 2, and 4. So if you do an OR on it, what do you get? You get
7.
You get 0, 1. This is 2, and this is 4. So you do an OR on it, you get 1, 1, 1, or 7. You see that? So this actually becomes a number. This OR operation just replaces, it's a single number now in the end.
But if you just put 7 there, no one's gonna like you as a programmer, so don't do that.
Yeah, exactly. I mean, I just made up those numbers. I don't know what the defines are. But it could be also, for example, that it won't always necessarily change the number. It could be that one of them is 5 and the other one is 4. If for example, if this is 4, and this is, let's say, the other one is Yeah, the microphone goes. Something's really weird in this thing.
I think it closed and went back up.
What?
I think it closed and went back up.
It closed and went back on?
8:38.
It stopped recording?
I just saw it inside.
How do I know if it's recording or not?
You probably open it full screen and it'll say,
Yeah, it's recording.
okay.
Okay,
My fault.
share.
Teach their own, you know?
I don't know, this is crazy. Okay, and let's go back to slideshow. Slideshow. Okay, so everyone got this idea? I give it open, I give it the name of the file, which could be like a full path name, then how I want it to open it, and then also this also number here. 0644. I think we learned that in the change, you saw those numbers with the change mode command. Right? Remember we saw the change mode command? You can have a file with different called access modes. Some people call it permissions. What it means is, what's the access mode of a file? It means who has access to the file. So it could be the owner, could be the whole world, could be just a group. So I have to give it, in this case, 644. The 0 we can ignore really. 644, what does that mean? It means 6 is the
Read.
owner. The owner gets read and write, and the rest of the world just gets read. So that's kind of a logical way to open a file. I can read and write. If I would open it with a 0 here, if I would open it with, instead of a 6, a 0 here, then it would be kind of crazy. Because I'd be opening it, but I can't write it.
What's the order of it? It's just read, write, export.
Yes. 4 is read, write is 2, and execute is 1. Okay, so we explained pretty much the 3 parameters. Notice that this parameter, whenever you see a function definition where the parameter is in brackets, it means that it's optional. So you don't have to give it a mode, and it'll have a default mode, which will be set by the system when you log in. Whenever you log in, there's a sort of a default mode for opening files. And you can change that default, but it's set. Okay, the file descriptor return. So this number that it returns here, FD, I called it FD because it's called a file descriptor. It's a number, like 1 or 2 or 3. It won't usually be 0, 1, or 2, because those ones are taken already. So it'll be probably, the first time you open a file, it'll be 3. Why are those first ones taken? Because
Input, standard in.
standard in, standard out, and
Error.
standard error, which means the screen is the standard error. In other words, if you write, you can write to a file. If you want to write to the screen, it's simply a file, and the file descriptor for the screen is 1 or 2. But this will give me another file descriptor. There's essentially for each process, there's a file descriptor table where the path is associated with a number. And we're going to see that we're going to use that FD in the next command. It'll always be the lowest, what's emphasized here is the lowest file descriptor not currently open. Here you see all the different modes that you could have. You see any redundancies there, Tusk?
Yeah, Tusk. Oh, is this gonna be a?
Maybe, I don't know, no, not really. Okay, but you see 7 over here and 4, they're redundant. Because this is read, write, execute group. And this is like a subcategory of that.
Yeah.
So it's logical that it would be a subset.
Which one is that? No, but like.
This is group has read permissions. This is group has read, write, and execute permissions. So if I give it 7, it would be kind of redundant to say, I could do an OR with SIRWXG and then OR it with SIRGRP, but that would be silly, but it would compile, it would work. Okay, close is the sister to open, and when you finish using a file, you close it. And actually, an important point, in my opinion, although maybe there's a debate about this, is that when your program ends, the files will automatically be closed, assuming you didn't create a fork. when all the processes that have that file open are no longer processes, then the file will be closed. So technically, you don't have to close a file at the end of your process, at the end of your program, because the minute the program finishes, it's not like if you don't close it, it's not like the file will still be open. It'll be
The
closed.
program is ended, so.
The program ended, so the access to the file has ended.
Close only closes.
Close only close.
Doesn't, it's in the name.
But sometimes you wanna close something,
Spare.
wait, Shy, sometimes in the middle of your program, you wanna close something because you wanna reuse, you wanna reuse that ID or whatever. So you don't, and anyway, it's considered good manners to always close something if you opened it.
Good manners.
Okay, so here we're talking, here's a little word about the file descriptor, which I sort of mentioned, and I'll mention it again. 0 is the standard in, which is the keyboard, 1 is the standard out, which is the screen, and 2 is standard error, which is the screen. Which means that if I write to either file 1 or 2, it'll go to the screen. But it'll go to the screen in different ways. It'll go to the screen either as an error or as a regular message. But the user won't see any difference, they'll just see text on the screen. The operating system maintains a file descriptor table for each process. On creation, the process will be so as soon as you create a process, it automatically gets these 3. So your program is processed. Once you run your program, you get these 3. That's how your program can do a printf and print to the screen. When open is subsequently called, open will return the lowest free file descriptor, usually 3. A row will be then added to this table indicating that what file 3 refers to, which actual path, what file name it refers to. Okay, so now we get to the exciting part, the read. Because once you open the file, you want to read the file. Now, what are the parameters here? The FD is the number that I got from open. That same number. Let's say I got 3, so it'll be 3 here. Of course, usually it'll be a variable. I'll have FD equals open, and then some number will be an FD, and then I'll use the FD over here. But it's really just a number, like all variables that are all integer variables are just numbers. And then I need 2 more parameters. Buffer, which is here it's defined as a void star. That's just to be the most generic way of defining an array. You do void stars, any kind of array. But usually you'll cast it to a character array, because you're going to read from a file, usually there are characters in the file. There could, of course, be binary data, and it wouldn't be necessarily characters, but whatever. You're reading into this buffer, because when you read from a file, you don't just read it into your mind, you read it into a buffer. You got to read it, and therefore you're writing it into the buffer. So read has a buffer that it writes to from the file into the buffer. And then the third parameter is the count. Now the count is how much you want to read. Now the largest value you should put in count is the size of the buffer. The buffer is 100, then count shouldn't be more than 100. It could be less, but it should be more than 100. And the read will not read more than whatever count is. And this will prevent buffer overflow. You don't want to write to a buffer 100 when the buffer only has 90 spaces in it. So usually you'll write the same number here. You might write 1 less. We'll see some examples where I write 1 less because I want to put something at the end of the buffer. So I want to keep a space. Read attempts to read at most count bytes from the file descriptor FD into the buffer starting at buff. In other words, wherever buff is pointing at the beginning of the array. If count is 0, what if count is 0? Well, it says don't read anything. Read returns 0 and has no other result. It don't, has nothing to do. It'll just tell you read 0 because you can't not read 0. The return value is the number of bytes read. So this return value is size t, or s size t. It just is think of it as an integer. It's just the word integer. So it returns an integer. What is that integer? That integer is how much it read. So if you wrote 100 here, it could write 50 here. What does it mean? It means it got to the end of the file after 50 characters. There's something left in the file. If it returns 100, it means that you're not sure that you got it to the end of the file. Like, there could be exactly 100, in which case the next read will return 0, and you'll know that you reached the end. But it could also return 100, and the next read will also be 100, and the next read will also be 100, until eventually it reads, let's say, 50, and then you know you've reached the end of the file. So the return value is the number of bytes read. 0 indicates the end of a file. Also, a number less than the count indicates less at the end of the file. If this number is smaller than the number of bytes requested, it means that either fewer bytes are actually available right now, maybe because we're close to the end of the file, or because read was interrupted by a signal, right? It doesn't necessarily mean you could get a smaller number because somehow the read was stopped in the middle. It never happened to me, in all my years of programming, that read stopped in the middle, but theoretically. On error, -1 is returned. What could be an error? What?
Wrong type of file, you say it's.
Yeah, you tried to open a file and it was a file only for reading and only for writing to, and you tried to read from it. So you an error. What?
We don't have permission to access.
Or you don't have permission to access the file, or
you write, but there's no room.
you didn't do open. The number that you put there is the wrong number. If the FD is like 25 and there is no file 25, then. Okay, so here's a little program. Open a file, read it, print the buffer, and number read. So that's we're gonna read a file. So here, what do? First, I create some integers. FD number read in. How many? That's my number read in. I want to know how much I read. And then I make a buffer of 256. It could be any number there. Open a file for read only. So I do open dot slash means in the current directory file dot text read only. So we've opened the file and FD has got a number, probably the number is what? 3. If FD is less than 0, always check, because don't start reading your FD unless you know that it succeeded. So if FD is less than 0, in other words, -1, then we failed to open the file, print file not open, exit 1. You gotta, whenever you're doing a system, a basic rule in system calls, whenever you're doing a system call, there's no guarantee that it'll succeed. So you gotta check that it succeeds. The operating system could say, I'm sorry, I'm not interested in opening that file, or there is no file, who knows what.
Could you easily just as easily check if it's less than 3? I don't know if that's easier for
You can check as less than 3, but it's not the standard way of doing it. It's less, right, I mean. Maybe, yeah, I mean, it would be unlikely that it would be less than 3, but. It wouldn't be, that's not really a failure. It's less than 3, it's not really a failure, technically.
It's not what you want, right?
It's not what I want, but yeah, but it's not a failure. This is the correct way, or you could do equals -1. Now we will read the contents of the file. So we say like this, number read in, which is an integer, equals read FD buffer 255. Notice I did one less than the size. Size of the buffer is 256, but we read one less. Okay. Now close. Yeah, it's just because I want to print. Close FD. So here I was being very polite. I closed the file. And now I say in buffer at place number read in. Remember, the number read in is, let's say, 10. So that means it read 10 characters. So at location 10 in the array, what's there? Garbage. Garbage is there because the 10 characters that I read are in 0 through 9. So at number read in, there's garbage. But I don't want there to be garbage. I want there to be a null so that the printf will work. Because printf prints just like cout. It prints until it hits a null. So there's garbage there. There's no guarantee what that garbage is. It might not be null. So I don't want it to print garbage. So I have to say, put the null in so that the buffer is quote unquote a string. So the definition of a string is a set of characters ending with a null. If it doesn't end with a null, there's just a set of characters. So I put the null in, and then I print, and I decide to print D, which is the number read in. D is a decimal number or integer. And I do a new line and number read in. And then I do print a %s, which is a string, and that's the buffer. So I print, for example, if the file had in it some 10 letters, then I'll print 10, and then I'll print after that the 10 letters. So that's just reading from a file. Open, read. Now write into a file. How does writing to a file work? Writes up to count bytes. So I put here a number. Writes up to count bytes from the buffer, starting at buff to the file referred to by the FD. Here's the FD again. Here's the buffer, and here's the count. It's the same parameters, but now I'm doing the opposite. I'm taking from the buffer and writing to the file, but I'm only writing at most count. Why would I write at most count? Well, it has to know how big this buffer is, for example, otherwise it'll just keep reading forever. Count could be smaller than the buffer size. I could make a buffer of 1,000 and then put in the buffer the word hello, and then I only want to write the hello, so I'll give it the string length of hello. And I'll put the string length of hello over here, for example. So it writes up to count bytes. Why does it write up to count bytes? If I told it to write 7 characters into the file, why would it write only 3? Why would it write less?
Maybe no more room.
What do we know more room? No room where?
Wherever you're ready to, maybe perhaps. This is full.
The disk is full.
We break it.
If the disk is full, I can't guarantee, when I try to write to a file, I can't guarantee that I'll write all of those characters. It could be that I'll write 0 characters, even though everything was fine, because there's just no room on the disk. I mean, usually that you have room on the disk, but could be you won't. If the file was opened with a pen, the file offset is first automatically set to the end of the file before writing, right? Just like a pen should. You want a pen to the end of the file. On success, the number of bytes written is returned. So, in other words, this size t, this integer here, could be less than count, as I explained, because it could be that there's no space. Note that a successful write may transfer fewer than count bytes because, for example, there was insufficient space on the disk device to write all the requested bytes. FF. And here's an example of to write from the standard input. So if I want to write to a file, I got to get some data to write. So let's see what I did. I didn't just write from a data like I just made up the word hello and wrote that to a file. I think what I did was a little bit more interesting. I think what I did was I read from the screen. So the person typed something and then it automatically goes to a file. So let's see what I did. Buffer, open a file for write and potentially overwrite its contents because I just did write only, I didn't do append. And I opened the file. I didn't just define the mode because I don't care, because I'm using the default mode. And the default mode will let me write. FD, check that FD actually succeeded. Now read from the standard input, which is the keyboard. We'll stop at the return line, the enter. So I do like this, read 0. What does 0 mean? Remember, that's the FD. The FD of the screen of the keyboard is 0. So that's the keyboard. Read from the keyboard, which is really just a file. Read from the keyboard into buffer up to 256 characters. What? Well, I call the keyboard wherever you input data from. Terminal, fine. TTY, you're saying? Yeah, it's the TTY.
Because isn't there like a separate file descriptor for the keyboard? For like the raw input?
There's a device, right? It's a device for the keyboard and then the TTY, but they're joined together. Yeah. That's what happens when you. That's what happens when a process is created. It joins together the device with the file descriptor 0.
Can you actually stream raw?
You can change that.
That's nice.
No, you have to open it. No, that's the whole point. No, but you could manually open it.
That's what I'm saying. Like when you
Yeah, I actually have a slide about that. You can actually manually open the keyboard yourself, but it automatically gets opened for you and 0 gets connected to it. So read from the standard input will stop at the null. So for example, read. I'm reading from the keyboard. Now what I did was just for good manners, I printed out the number. And I printed out the number how much I read, just to prove that I read something. Like he typed in hello, and I type out, let's say, hello would be 6, I don't know, something like that. So, because it includes the null. And then the null, and then the backslash at the end. HELLO backslash, so 6.
Null is automatically put in there.
Not null, backslash. No, backslash. No, backslash. When you hit enter, it read that enter. It's a backslash n. Sorry, a backslash n. New line. Sorry, I said backslash, I meant backslash n.
We don't have to put in backslash anymore.
You hit enter and it reads it as a \n. So it'll read 6, it'll print 6 here. We can try this out and you'll see that I think it'll print 6. So it'll print 6 and then what do? I write to FD, which is the FD that I opened, which is file.txt, write to FD the buffer that I got, and then I don't write 256 because I know that I only read 6 characters, so I just write 6 over here. So I'm going to write only 6 to the file. Then I say, look at this. What does this do? Write 1 buffer and 6 again. So what's 1?
Standard out.
Standard output. I don't have to write 1. I could write stdout, but I write 1 just to be clear. 1, and in fact, it's better to write stdout, but I like to write 1 just to be contrary, just to show you that it's a number. It's not like some magic. It's not like some magic word here. It's just a number. So I write 1, which is the screen. So now not only did I write it to the whatever he typed hello. I wrote it back to him to the screen. I also wrote it to the file. Then I close the FD, and then I do again via printf, and I print s, the buffer. Now the problem with this buffer is it has no null at the end. So it'll be a little bit problematic what I do there. I really should have put a null in.
The backslash is not counted as null.
No.
So you have to overwrite backslash n and make it null.
Yes. The \n is not null because I could hit right because it's going to give me a new line. So this So printf will be a little bit problematic here, whereas write won't be. Write won't print because write, I told it print only 6 characters. So when it printed to the screen with the write 1 buffer number, it printed exactly 6. But when I printed with printf, I don't know how much it prints. It prints however much garbage is there until it happens to hit a null. There might in the garbage there might be a null, but I don't know where that null is. I don't know where that first null is. Okay, there's some other. Okay, there's a whole nother way of opening files, not with open and close and read and write, but with fopen, fread, and fwrite, F standing for file. And what are these functions? These are a whole family of functions that are wrapper functions for the primitive function open. We have the primitive function open and close. Then we also fopen, and some people like to use the fopen, sometimes they're more convenient. So I wanted to explain them. So it's a set of wrappers. So we have fopen, fread. They also have some other functions that I'll talk about them actually mostly. Fseek and rewind. But a set of wrapper functions was written to make it easier to open, read, and write to files. These functions call the low-level functions read, write, and open, etc. Example on next slide. So I actually prefer the regular primitive open and read, but I want you to know how to do both. So it's a little bit different because the file descriptor is not just a number. It's this special type called a file. I don't know exactly what that type is. It's a special type. I never really investigated it, but it's a special type called a file, and it's a pointer. So file pointer FP, and then when I do fopen, it returns to me a file pointer, not a file descriptor. It's a file pointer. That's why I didn't call it FD. And it's specifically a type file. And that's what fopen returns. And notice here, I just write R. I don't write the numerical value, I just write R for read.
Maybe it's not just like an IO stream and file pointer is not true. You can't stream from a file pointer.
Stream is really a term more associated with C++ than C. I never heard that. You know what I mean? Like, that's what when you do C out, the arrows, that's the stream. I don't know
You can't do that.
I don't know. My explanation is that it's a wrapper function for the other function. What you're asking? Is it a stream? Yeah, I think you're right. Yeah, I think you're right. It's a stream. But exactly what that right here, you see, I say stream. It is a stream. But fine. What is a stream? You have to explain that. Now, let's just leave it as it's a different type. So I made a buffer and a big buffer, and I opened the file and I checked. Now I don't check that it's -1. right? On failure, the pointer won't be assigned. It'll be null. The pointer. Did the pointer get an address or did it not get an address? So I check if the pointer is null, then I didn't succeed at opening. Then I say, this is commented out actually, so I'll skip that. Oh, I'm here, no, this is commented out, what is this? This is the prototype. This is the, if you want to know how to call the function, you gotta look here. This is how the function is defined. It returns the size t, which is an integer. It takes a pointer, a regular pointer, a void pointer, any kind of pointer. It takes a size, which is an integer, and another size, and then the stream. You see a file star stream. Here's the stream, and that's the FP that I'm going to give it. So I give it the FP that I got, and I'm F reading into a buffer, and I do size of character because it's a little bit confusing here.
That's what it's, yeah.
It's confusing, but it's meant to be easier because I can read. It's saying like this instead of telling the function, I want to read 400 bytes. What we do is we say like this. Well, it depends what I want to read. Do I want to do characters or integers? If it's integers, then I'll write size of integer, which is 4, and then I'll write 35, and that means 35 integers, and it'll do the math. It'll say 35 times 4 is 140, and it'll be like I did read on 140. It's a little easier for me because I just tell it the size and then how many of those things, and the multiplication it'll do internally. So that's the way the function is designed. It's a buffer, then how much to read into the buffer, and then the stream pointer, the file pointer. So I read, it's basically the same thing as the regular read, but in a different way. And now I do a whole bunch of things, which is minimize this. First thing I do is I print the whole buffer. Then I print the word junk, just to show that I finished printing the buffer. Then I read. Well, what am I doing there? I'm reading from the file into the buffer. And then I print the buffer again. So let's see, wait, what do we get? What's the buffer? In the beginning, the buffer had nothing in it, right? It was just garbage. So what did I get? Well, this is the content of the content of the file is this is the first line. This line has 34 characters in it. This line has only 17. So does this line. And then 1, 2, 3, 4. So I think there's a blank line here. Basically, the buffer had a null in it right at the beginning, so it didn't print out anything. So this first line where I said print buffer, it printed nothing because the buffer was empty. Then I said printf junk, so it printed hopefully the word. I guess this output is not 100% right. Oh, here. Wait a second.
So what should be?
Printed the first 1.5 lines.
Wait, the contents of the file is this.
Yeah, that's the buffer.
That's what it starts as. This is the first.
No, the buffer is empty. Look, here's the buffer. The buffer is
That's
empty.
a jump right in the middle there.
That's this junk because
That's in the buffer.
I must be missing a line here. Oh, here, I'm sorry. Here, F3. I'm sorry, I misread my code. Here, here's the first read here. And I'm reading 35 characters of the file into the buffer. So the buffer does have something when I print it here. It has 35 characters. And that's what I see here. This is the first line, this line, because that's 35 characters of this buffer, of the file. Then it prints junk. This line because it doesn't have, I don't have enough space to get all of these. I only read 35.
Because that's in the buffer? Oh, no.
That's in the file.
That's the file.
And no, I printed the whole buffer. But the whole buffer is just part of the file. Then I print junk. Then I read again 35. So what's going to happen now?
The next 35.
The next 35. So that's what it says. The has, the And then the has 34 characters in it. This line has only, and it stops in the middle of the word.
Oh, and then we were like.
Because it read another 35. Now I rewind the file by doing rewind FP, which means bring me back to the beginning. And then I do again read 35. So again, it should print. Now I rewind the file. This line is the first line. This line pop. Now I rewound and I read, and now I jump ahead 23 characters. So here's fseek. Fseek means go forward by 23 characters. From, what does seek current mean? It means from the current location that I'm at. Because I could go 35 from the beginning, or 35 from the end backwards, whatever. So this is from the current, go forward 23 lines. And then I read again 35 characters, and now I jump ahead 23 characters. This line has only 17, so does this line jump. Because after I printed the buffer, I printed jump. Now I rewind again. And I rewind, and then I read into the big buffer 350. So now I rewind again. This line is the first line. I get the whole thing because the bigger buffer was capable of holding the whole file. Rewind again. Okay, you got the idea. Close, and I do F close to close. So this is how you work with a file, basically with the F family of functions as opposed to the regular open and close. Topics for further learning. In other words, things that I'm not explaining, but and I'll tell you which of these things you do have to know for the exam. You don't have to know these ones. Function control, FD open, select, or polling, but you should know string copy, string compare, and string cat. You probably saw them already in your
Shonda class.
in your other class with in introduction to computers introduction to computer science. Why Shonda? Shonda?
Shonda. Sorry, Shonda. My bad.
Shendel? What are you talking about?
Like brown shirt, brown pants.
That's
Straight off.
He's a teacher named Shendel.
You don't have
Mustache up the wazoo, eats broccoli.
a thin guy?
He was like
Briefing
broccoli. Like, well, they eat broccoli.
What's his first name?
Fine.
You don't have Ethan?
Fine.
You don't have Ethan Marcus?
You didn't have other classes.
What do you have with Ethan Marcus?
Automata.
Really? You don't have introduction to computer science?
No.
What?
We used to have, I think.
We had-
He used to
Sorry.
teach, he used to
No,
teach
we had
introduction and data.
We had him just run computer science. That was 3 years ago.
Yeah.
You did. So you did, but they had somebody else.
Yeah.
Okay,
So we have to know SDR.
you have to know these ones. You also have to know 2 upper and 2 lower. Guess what 2 upper and 2 lower do?
Uppercase, lowercase.
Exactly. See, you already know it.
That's I know those from Python, right?
Memset. Memset is if you want to take a large area of memory and set it all to, let's say, the value 7. So you can memset. And memcopy is you can take a large area of memory and copy. Get n, we have to talk about get n. I think I have a slide on it. Malloc, you have to know. Malloc is creating memory, and free is
Free
freeing memory.
Oh.
String toke we have to talk about.
That's where you get this first.
And the rest of them you don't have to know. Wait, I don't have a slide. I thought I had a slide on string toke.
So get UIT, set VG ID. We
Yeah,
gotta
let's-
use STR token in the homework, and one of the homeworks asks for that.
Right. So let's talk a little bit about str toke and getN. Well, getN we're going to talk about later, but I'll talk about it now again. Before, so that when we talk about it later, that'll be get.
Yeah, I think homework 5 dealt with both of this.
Let me talk about these 2 on the board. Wait a second. Okay, so now you'll see me bigger a little bit here. This is exciting. I'm gonna write something on the board. It's interesting. I find the better I know something, at a certain point, I know something too well, and I don't want to teach it anymore. It's always more interesting to teach something that you know 80%, because then you still exploring. Anyway, but then the students sometimes don't like that because they like the teacher to know every single thing. So wait a second,
It's
so
an
let's,
adventure together.
I prefer adventure together. STRTOK. What do you give it? You give it first null. And then you give it some kind of character array. Some char star. So let's say like string. We'll call it string. Now what does it return? What it does is it returns. Oh, I have to give it a token by which to tokenize it. I don't remember the order exactly, but let's say I do like this: space, string. I think that's the order, but I could be wrong. You could check. Can we check it? You guys can check it. Somebody check it. What's the order of the parameters of string token? Thank you, Shai.
That's.
That's good. That's the way.
This last one is slow.
Yeah, that's what I'm not sure.
I did this last night. It is.
Google is confused.
Yeah.
It would be the other order.
Strict off only takes 2 arguments.
No, it has to give it. I have to.
The input, where is it? No, I missed.
Oh, you're right. What the first one is?
Oh, there's a bunch of over. It takes a.
See, I gotta remember.
You cannot use null immediately because you need to
Right.
to know where you're reading from.
Right.
You need a variable.
STR.
Yeah, the first time you use it, you can't do null, you have to put in the file descriptor. And then
Right.
when you pass a null, it reuses the same file descriptor from where we left off.
So it takes the character and then the limiter. So it's here. So it's like this. You do string. That's a string, comma, and then space, for example. So what that does is if my string is, let's say, hello world. Let's say my world is, this is my string. Hello world. I don't know, today. Let's say like that, today. That's my string. Now, string toke will actually give me a pointer to the hello and put a null here, backslash null, a null like that. So what it does is, so if I actually try to print now this pointer that it returns me, P, let's say. So if I do a print on P, well, what is printf gonna do? It prints until it hits a null. So it's gonna print hello, and then hits a null, so it'll stop printing. So it's as though I got just a hello. But really it just stuck in that there and put the pointer there. Then if I call it again, str toke, because I want the next token, I want the next piece of the string. So str toke, and I give it, now I write null, and I write again space. So what I'm saying is like this, when I write null here, it says use the same string that I gave you last time. How do you do that, by the way? How do you have a function that remembers state? Called state. How do we do that? Did you learn? You should have learned. Static variables, very good. So you have a static variable. So null is now telling it use the same string that I had before and divide it again by a string. So now it's going to give me a pointer to here and put a null. And then if I call it again, and it'll give me P, if I print out P, now P will be world. And if I call it again, str toke null. Well, what if I don't write a null and I write the letter D? Then it's going to give me a pointer to here and get rid of this D and put a backslash there. And it's going to print 2 now. Because I changed the delimiter now. I can change the delimiter in the middle. Now the weirdest thing about string tokenizer here, let's see. See if anybody knows this. What does it do if I write, let's say, space D?
Splits on both,
What does that mean?
it splits on spaces and also on.
I mean, either or.
Yes.
It splits on either or. It's not that I'm looking for a delimiter that is space D, but it means I'm looking for either a delimiter that's zero, that's space, or a delimiter that's D, whichever one first.
Not like a regular expression.
So that's how string token works.
What about just wanting that space D?
Now, why is this useful? This is useful because let's say the person didn't write hello. Let's say you read from the string, you read from the screen by doing read on 0. And now the person wrote, let's say, for example, let's say he wrote ls minus L file 1 file 2. Now, if you want to figure out what command he gave you, because you're the shell, you got a whole string. Your string is this whole string. That whole thing he hit enter at the end, that's your string. But you want to get the first piece of the string. So you need to do string tokenizer to get the ls. And then you want to see if the next thing is a flag or a file. So you got to get the next piece. And is it a minus? Does it start with a minus sign? Then it must be a flag. Does it not? Because files don't start with a minus. You cannot have a file that starts with a minus. But if it's a minus, then it's a flag. And then the next field and the next field. So you're going to want to go a loop of string tokenizing, a loop until when? Until there are no more strings. How do you know there's no more strings?
Oh.
Exactly. When the pointer that it refers you back is null. When it gives you a pointer which is null. So that's string token. There's another function that you should know that I want to explain, which is I think I explained it in the slides, but I'll explain it now. And that is the function get end. And basically I give it a name of a variable, environment variable that I want. For example, path. Path is an environment variable, which is my personal path where I check to look for files to run. Like if the guy types in ls, I'm going to go to all the different paths. What does the path look like? The path actually looks like something like this. /user bin : /bin : etc. And what they are is paths separated by colons. I don't know, /sbin. So let's say this has 3 paths and it's separated by 2 colons. And again, I'm going to use string tokenizer on this, but my delimiter will not be a space this time. It'll be the colon. And I'll get this piece and this piece and this piece. And that's how I'll try to find the command that he typed, let's say ls. I'll append it to this. I'll take this and I'll say /user /bin /ls. And I'll try running that. And if it runs, then I know I found it. If it doesn't run, then I'll try the next one. So get end will give me a string. What string? This string, the string that is equal to the path. And I can give it different variables. I can do get end home, and then it'll tell me my home directory.
So why is it multiple paths?
Well, the path is multiple paths. The path, the environment variable is a list of all the paths where runnable programs are kept.
Any runnable?
Yeah. Okay, let's continue from the slides. And we see, so we explained string toke and we explained get end. The other ones you can figure out. Okay, now we have another function called fork. This is a fun function. What it does is it lets you create multiple processes from one process. What?
It forks.
It forks. Which means that if you have a process running. And now your program is running, so it's a process. And now all of a sudden you want the process to do two things in parallel. So you need two processes. So your program needs to create a child process. So you do that with fork, and then both processes will run in parallel. So how does it work? You just give it void, you don't give it anything, but it returns an integer. PID type is integer. So it returns an integer. Now, what integer does it return? Well, the minute you call fork, you essentially have two processes. Each process will get its own integer. And there'll be different values. That's a key point, which is hard for people to understand. But once you call the function fork, it returns to, now you also have two processes. So each one gets a value, and they're not the same value. So let's read what it says here. Fork creates a child process that differs from the parent process only in its process ID number. It's PID. Not Philip I. Dancing, but my father's, but process ID. And its parent process ID. Because the child process's parent process ID will be the one who created it, the father. And in the fact that the resources utilization is set to 0. Fine, it's not using any, it's not using, it is actually, the same files that were open will be open for the child. If a father opened a file and now the child is created, they'll both have access to that file. So I'm not exactly, I don't have a good grasp of what exactly the utilizations are, but I never bothered to check. File locks and pending signals are not inherited. So in other words, if there's a signal that was sent to the father, and the father didn't yet receive the signal, and then he creates a child, the child won't get the signal, the father will get the signal. A call to the fork system, well, so here's the answer. A call to the fork system call returns 0 to the child process and the child PID to the parent process. It's like this. When a child is born in the hospital, the child gets nothing. He doesn't get anything, but the parent of the child gets the number, the ID number, the absolute number of the child. Just the mother. So the mother gets the ID number of the child. The child, is it her ID number? No, it's her child's. Does the child get it? No, the mother gets it. So distinguish between gets the number and the meaning of it. So let's see an example. So in this case, I have a very simple program, about as simple as you could be. I say like this, int a equals 9. Then I have an integer called value. Basically, it's an integer, and then I say value equals 4. Now, at the minute I call that line, I have two processes running. They are both going to they're both going to run the line printf. One of them will print my variable value is some number. And the other will print my variable value is some other number. What are the two numbers they'll print? So it's like this. Of the two processes that are created here, the child process will print 0. Because this value will be 0 for him. It's like I said, the child that's born gets nothing. But the parent who created the child, he'll get as his value here a number, or not 0 number. And that number will be the PID of the child. So the father will get the process identification number of the child that he created. The child won't get it. Of course, he could find it out because there's a function called get PID, which I can call and then find out my PID. But the child isn't given it at this stage. So here I can use the fact that the numbers are different to create parallelism that is different. In other words, I want to have two functions running in parallel but doing different things. How can I differentiate? So I'll take the same program, but I'll call it PID since it could be a PID number. It could be a 0, in which case it's not a PID number. But it could be a PID number, so I call it PID. And then I say if PID equals 0, then what? Then I must be the son process. So I print out, I am the son, I don't know my own PID. Else, that means the PID is not 0, it's some other number. In that case, I am the father. I don't know my own PID because I didn't do get PID myself, but I do know my child's PID, and I print it here as D, and then I write a PID. So you see the PID in the father has the value of the child's PID. And now this if and else, this will print once and this will print once. Because they're separate programs running. A normal if else, only one of them gets printed. Here we have an if else where 2 gets printed, both of them get printed. So there's 2 different processes running them. Now, what about this case? This is a great one. Here I say an example showing that multiple calls to fork creates more processes by a factor of 2. Look at this. If fork equals fork. How many processes will get created in this? In this case, how many processes get created? Or how many processes total are running by the end of this? Well, this one creates 2. And the equal sign is executed from left to right. So first I execute this side and I have 2 processes. Now both of those processes go to the right side and see something over here and execute that. So that means each of them executed a fork. So I got 2 times 2, which is 4. So I have 4 processes. Now the question is, when will the value on the left side be equal to the value on the right side? I don't know. You're probably right, but you didn't say it. Well, I want to still draw a picture.
The last fork, well, the one who does not fork anymore, one who got back, the first fork has 0 because they were a child. Process and then when they forked, they also were a child.
Yeah, you're right, but let's draw it out for the human among us. You're right. For the slower people, I'm saying you're beyond humans.
So that's your subject.
I'm saying for the people who are a little bit
Yeah,
slower,
yeah.
that's a bit quick to get that. So let's say like this: the fork on the left, I have a fork over here. And what is it? What value does it produce? Well, it produces 0. Who gets a 0? The child. And what does the father get? The father gets some number. What number? The number of the child. Let's give him a number just for clarity's sake. Let's say the father gets the number 7178. That is the child's PID that the father got. So that's on the left side. Now on the right side, the child went over here and he called fork. So he got a 0 because who got the 0? The child, actually. The child's child got a 0, but the child himself, now a father, because he created somebody, got the PID of this child, which is, let's say, 7179. Now the father came over here and he also saw a fork. So who got a 0? The child, which is the brother of child. Let's say child 1. So let's call this child 1. And let's call this child 1. But anyways, the brother of child 1, the child. And also the father got the number of that child's ID, which is, let's say, 7180. So now the question is, when is the right side equal to the left side? So let's check. Is 7178 going to be equal to any of these numbers? No. So that just gets rid of that possibility. What about 0? Is 0 going to be equal to any of these numbers? Well, it's going to be equal to this 0. Technically, it's also equal to this 0, but it's not running at the same time as this. This 0 is only in the world of the father. By the father, he got this number, and he's comparing it to these 2 numbers, and it's not equal to either of them. By the child, he got this number, and he's comparing it to these 2, and it is equal at one point. So when is that? When the child, who was 0, he creates a child. When the child has a child, they're both going to be 0. So it's going to print hello how many times?
Here's cancer child, he gets his child's PID.
Exactly, that's what I wrote here. Here's the child,
So he'll never have,
But in the first.
that's the PID of this child's child.
why would you get a zero?
Yeah, why would they both get zero? In the first fork, in that expression,
Yeah.
right, there's only two processes, and one that has zero.
Yes.
Then it splits into two more,
Yeah.
and then it's null, and then one of those into zero also.
Yeah, why would
as
one
it
of the
goes along.
subsequent ones also? No, I got, we said that there were two, that there were two.
You thought you knew it, but now you don't.
No, no.
He just so
I don't know why you
Turns out he sucked.
I just explained what you said before.
Hey, right, so I thought you said there were two, that there were
He
now
said-
two.
he said that on-
Two processes, I'm saying.
What?
I'm saying, I thought you were saying.
I don't embarrass you. Let's get your question clear. I'm not
Are
embarrassed.
there one or two processes?
You're paying attention, almost everybody else not paying attention, so.
I'm saying that there was one process, is that correct? That will print.
There's four processes.
Four processes, and one of them will print hello.
One of them will print hello. Who? When the child has a child.
I thought for a moment we said that we concluded that there were two processes at the end that had.
No. There's the child and the father has this number over here on the left. And that number will never be equal to anything on the right.
The grandson.
But the child has 0 over here, and that could be equal to something on the right, because it could be equal to the 0 that his child got. So it'll print exactly one time hello. How many times will it print bye?
3.
No,
Not every time.
which is
Four times.
4 times.
Oh, okay, yeah. Okay.
There's not an else. Well, that's good. You guys got forks now.
Wait, I did that last year. Why is it creating four?
What?
Creating children zero? They already have zero. Like it seems dumb.
What the child is PID